All right, now that we know some things about mathematical statements and implications, I want to go over some examples and kind of talk through those and determine if they are true or false. So let's make this bigger. All right, so statements and implications examples. So recall that an implication, we read this out loud as if P then Q is true when the hypothesis is false or the conclusion is true. Okay, so the hypothesis is the P, and here on the first column of this table, we have the P could be true or false, and then the conclusion is the Q, and here we have the true false for Q as well. So notice that in this truth table, when the hypothesis is false, so P being false is the last two rows here, and we get true for the value, the truth value of the implication if P then Q, and then or the implication is also true if the conclusion is true. So that's the first row here as well as the third row. And the only case where the implication is false is if the hypothesis is true, or the P is true, and the conclusion, the Q, is false. All right, so what we want to do is, I have some implications here. We just want to know if they are true or false. All right, so the first one is, if 1 is equal to 1, then most horses have 4 legs. Okay, so we're looking at this in kind of two pieces. The hypothesis part is 1 equals 1, and then the conclusion part is most horses have 4 legs. All right, so clearly 1 equals 1, that's true. Most horses have 4 legs, that is also true. So if you're thinking about this in terms of the truth table, we're in this first row here where P and Q are both true, and that means that the implication is true. You can also think about this as being true because the conclusion, in this case that most horses have 4 legs, is true. Therefore, it makes the implication true. All right, let's look at the next one. All right, so this one says if 0 is equal to 1, then 1 is equal to 1. All right, so here's our hypothesis, 0 equals 1, that is clearly false. 1 equals 1, that is clearly true. So again, if we go back, think about the truth table, find the row where P is false and Q is true, and that is this third row here. That means the implication is true. So I know that this kind of sounds a little bit weird, but we're looking for the mathematical truth value of it, and that means the implication is true. Okay, so it doesn't matter that 0 equals 1 is actually false. The implication is true. All right, next example. If 8 is a prime, then the 7,264th digit of pi is 8. All right, so again, we're thinking about this in two pieces, the P and the Q. The P here, if 8 is a prime, that is clearly false. 8 is not a prime number. And the Q is the 7,264th digit of pi is 8. And honestly, I have no idea whether that's true or false. But the good news is it doesn't matter because we want to know if the implication is true or false. And because the hypothesis part is false, that means that the implication is automatically true. Okay, so again, going back here, if the hypothesis is false, that means the implication is true. So because 8 is not a prime number, that means this implication is true. All right, last one. So in this case, it says if the 7,264th digit of pi is 8, which again, I have no idea, but thankfully it doesn't matter, then the conclusion is 2 plus 2 equals 4. So 2 plus 2 equals 4 is clearly true. That's good. But we don't know about the first part. So the conclusion is true because 2 plus 2 is equal to 4. And that means that our implication is true. All right, so I hope those examples help. If you have any questions, just let me know. Thanks.